So far we've been talking about how data is digitized using binary system. So we saw how letters are converted into binary system by either the ASCII code or UTF-8 or UTF-32. We also saw how float 32, which is called the single precision, and float 64, which is the double precision. We were talking about that last time. We also talked about how pluses and minuses are encoded as the very first bit of a long integer, 64-bit integer, stuff like that, right? So we will actually try to see the amount of memory used for different data types by using numpy. Now, the reason I'm using numpy is because in original Python, everything is an object. NumPy to NumPy arrays are objects. And objects have not only the data, but also the functions, the methods along with it. So there are some overheads on top of the data, which is not the case for C++. If you're programming in C++, if you declare a variable as double float, then it takes up exactly 8 bytes of memory in the memory space. There's nothing more. But in Python, if you have a number like a equals to 3.45, this is a double float, and because this is an object, it has extra commands in there, and because of these extra stuff in there, it takes more memory space. Okay, so let's import numpy as np, and let's try to look at different types of arrays and see how much memory it will take. Okay, so let's say a is equal to np.array of, we have to provide a list, so let's just put 1, 2, 3. So if I do dir, and there's several things in there, and the thing I want is n bytes, which gives you the number of bytes the data portion takes up. See, it has extra overhead because this too also has lots of different methods, but we'll just look at the amount of memory the data type will have. Okay, and then d type. Data type is another thing. So if I say what is a.d type and enter, it will say int 32. Okay, who can tell me what this int 32 means?
32-byte bit integer?
Yeah, it's a signed integer that's 32 bits, right? So how many bytes? 32 divided by 8? 4 bytes. Okay, so if you look at A has 3 integers, and each of these integers are 4 bytes. So how many bytes should this one take up in the memory? A dot n bytes. 3 times, you just said 4, right? 3 times 4, so it'll be 12. Okay. So it's going to give you 12 bytes. Okay, now let's look at some other ones. If I do np.array with 1.2.3. Let's see what A is. Now you see that this response is slightly different from the previous response, right? The reason for that is once I put a dot, this is a hint to the Python saying that I'm thinking of this number 1 as not an integer, but as a float point, floating. So this can be a decimal. So if I ask what d type is, it's going to say float 64. How many bytes? 64 bits. So how many bytes? 8. Right? 8 times 8 is 64. So, and then if I ask what a.n bytes is, it's going to give you 24 because everything is now 8 bytes each. Right? And these are double float. Now, however, we could, and by the way, if you provide mix of those, in Python arrays, NumPy arrays tries to be, the NumPy array package tries to be as efficient as possible by using only uniform type of data. So if you put 1.2 and then 2 and 3, you only have 1 decimal, and you put it like this and ask what A is, you'll see that it thinks of every one of these as decimals because any integer can be expressed as a decimal, whereas the other way around, it's not good, right? So that's why numpy array does that, converts everything into a uniform standard thing. And sometimes if you provide something different and you cannot change that to other, it will complain. So if I do 3, oh, it worked. Okay. Oh, yeah. So I see. If you put a string, then everything will be string. Okay. Right. Okay, so yeah, but strings I want to do later. What I wanted to do was, np.array 2.1, comma 3, and then I want to say dtype equals to np dot. So in the numpy package, there's the float 32, which is otherwise known as the single precision decimals. So sometimes if you're running a machine learning algorithm and you're using some numpy arrays at some point, and if it's running too slow, or if the memory is too big, then you could make this decision. You could say, oh, well, my calculation doesn't need that much of a precision. I can work with single precision rather than double precision. Then you can just use np.float32. And you have a as this, and you can see that a.n bytes is now only 12 because single precision is 4-byte float. So these will only take 4. So by taking a hit on the preciseness of your calculation or the preciseness of the data that you store, you've managed to reduce the data footprint by half. Now, if you're working with big data, decisions like this could be very important. Okay? You want to think about the type of data you're trying to store, and sometimes it makes sense just to use float 32 rather than float 64. Okay, now let's move on to strings. So if I say a equals to np.array, this is test. Let's use a dot period at the end as well, and then enclose. Let's see. Now let's look at a.dtype. It will say u5. Okay, so what does u5 mean? What this is saying is here you have U for Unicode strings, okay? And then the length of the string cannot be 5, more than 5. Okay, so it's like less than 5, but it really includes until 5. So the reason it uses 5 is because the longest string here is test dot, right? And this is 5 characters. Because this is 5 characters, it's using it's saying that this array cannot have more than 5 characters. If I try to change the very first letter, the very first string, as something like this, that's okay, doesn't complain. But if I put this, it doesn't complain, but you can see what happened, right? I asked the very first element to be replaced by this, but it only contains this much. Why did that happen? Because our data type only allows you to have at most length 5 strings. And that's why it will cut off after the 5th letter. You can see this for the other part as well. A1, if I say, yeah, if I do that, then if I ask what A is, you'll see that only the first 5 characters are saved. So in other words, when you initiate a numpy array with a bunch of characters, then the dtype will be determined, and that dtype will be the longest string. That's how it's going to be determined. And now you will have only 5 character allowance for each of these places. All right, so now let's think about what's the n bytes for this. Okay? So first, let's look at n bytes. 80. Oh, that's a mystery. How do you get that 80? Yeah.
Well, it's 5 bytes for each word and 4.
Well, first of all, you see that there are 4 elements, right?
Yeah.
And 80 is divisible by 4, right? So if you divide, it seems to be saying that we're assigning 20 bytes per each string. Why? Why 20 bytes per each string? Okay, think from number 20, what number is related to this data?
Well, there's 5 letters.
5 letters, so that means each letter is
4 bytes.
4 bytes. Okay, what kind of encoding uses 4 bytes per letter? Unicode, which one? There are several versions. So there's a Unicode, there's a UTF-8, there's a UTF-16, there's UTF-32. Which one?
UTF-32.
Yeah, UTF-32. 32 is 4 bytes. 32 bits is 4 bytes, right? So what it's telling us is that when you have numpy array of strings, it automatically chooses Unicode 32 to represent each string, and then it says it's limited by the length. Okay. Now the reason that numpy uses UTF-32 rather than UTF-8 is because UTF-8 and UTF-16 are both different lengths. They use smaller bytes for more frequently used letters. So your usual alphabet A, B, C, D, E. In UTF-8, it only uses 1 byte. Okay? But in UTF-32, everything must use 4 bytes. That's how those two things are different. Okay, now let's move on to images. So we also talked about images. So how do we import images in Python? Well, you have to use something called PIL. So from PIL, it has to be capital, import image. Notice the capital I in the beginning. Now, some of you might have an error. That means you don't have PIL installed, so you might have to do pip install pillow. So if you do that, it's going to install pillow so that you can use PIL. Did anyone have an error when you did this? Everyone's fine? Okay, so maybe it's in Anaconda, they have it by default. Now, we have to load the image, and I have an image ready, and I uploaded it on my website. So let's say URL is equal to HTTP, could be HTTPS, it doesn't matter, 100worksheets.com, CS202, and cat.jpg. All right. So I have this as the URL just to give you a peek of what I'm trying to do. Let's copy this address, paste it. It's this one. It's a AI generated image, as if internet's lacking any cat images. Created one of my own. I didn't want to overstep some copyright, so I just made it on Gemini, or was it Copilot? I can't remember. So anyway, so this picture of the cat is what I want to load. Now there are 2 ways to go about this. We could just right click and save image and load from a local file, which is easier, but let's just use request to do that. We already have the data. We already have the URL, so let's do import requests. If you're using Anaconda, this should be okay. With the original Anaconda. If it's not there, you may have to do pip install requests. Okay. All right, so you do that, and then we have to say response, and we will do requests.get URL, and if I ask if the response was okay, oh, that's not good. It says false. Actually, while preparing for this lecture yesterday, I spent like a good 20 minutes trying to figure out why it's not fetching the cat picture. I mean, if you look at response.content, it says it's denied by mod security. So this is something that's automatically installed in many of the websites, even for mine. So to make sure that mod security is not going to block yours, you have to provide who you are. You have to tell the website who you are. In some cases, they're more strict and they only allow browsers to get their resources, but mine is not that strict. So all you need to do is headers equal to, you need to feed a dictionary. And in the dictionary, you just have to say user dash agent colon and then say Python. So I'm just using a Python script to get this, and then the mod security is happy, and I think it was okay after that. Let me just see. Response.okay. Good. So it did get the content. I wish now that we have the response.content, we can just easily change that to image, but the thing about the image library from the PIL is a Python image library. That's what it means. And it got discontinued, so other people forked the project, and now it's named PILLOW, P-I-L-L-O-W. So in that package, you have the image object, and you can do image.open. But sadly, this image.open only accepts like something like a file, opens and identifies a given image file. So you have to make a separate thing that will treat a Python variable as if it was a file object or something. There's such a thing. I need to do import from IO import bytes IO. Yeah, see, sometimes this dir is very handy because you might not spell it correctly and you have to figure out which one it is. Okay, so from IO import bytes IO, and then like file as if it was a file. We're going to use bytes IO to read the content of the response.content. This resides in the memory, right? And this thing is handled by this bytes IO as if it was a file. So now you can say cat equals to image.open this like file object. And then to see whether we did it correctly, we can do cat.show. Yeah. All right, that's the file. Okay, it made this temporary PNG file and showed it for us. But this is still a Python image object, so it has a lot of overhead. Just to look at the data content of it, let's turn that into a numpy array, and then from numpy array, let's look at what's in there. Okay, so cat np, cat numpy array would be the numpy array of the cat, and let's see what's in cat np. Oof, all right, so you see that once I did what's in cat np, I see a bunch of these numbers, right? A bunch of these numbers. And it says D type is uint8. Now U means unsigned. So uint means unsigned integer. 8 bits. So how many bytes? 8 bits. 1 byte, right? So you have 1 byte. So each of these integers are really unsigned integers with 1 byte, which means the lowest number this could be is 0. The highest number this could be 255. Okay, who can tell me what each of these numbers mean? RGB, yes, these are RGB values, right? Red, green, blue. Right? So, for example, if you wanted only blue, so let's think about this. We had a cat picture. Let's say we want to put a blue square at the center. Replace part of the picture by a blue square. So how do we do that? Let's do a cat np.shape. Okay, so what does that mean?
Well, 400 by 400 would be the resolution.
Yes, it will be a cat picture that's 400 pixels wide, 400 pixels tall, and each pixel will be given by this RGB data. That's what it is, right? What I want to do is I want a 40 by 40 square at the center of the picture. Okay? So how do I do that? Well, let's first review numpy 0. So if I do numpy 0 is 40 by 40 by 3, and then we will need to put the type equals to np.uint8. Okay, so it's going to give you 0, 0, 0. That's this size, right? But then this will be only 0, 0, 0s, which are black, right? If all RGB channels are zeros, it's black. So if I want blue, I want this to be, this last one to be the maximal possible. What would that number be? 255, yeah. So what I'm going to do is now add to this np.array of 0, 0, 255. This first one is a numpy array of arrays. It's a triple dimensional array, right? So if I add to this a single numpy array with length 3, notice that for this one I didn't write uint8. That's okay because any integer, when you add to this data type, it's going to be converted to uint8 anyways. But then, because this numpy array is the innermost array, these two things are going to be computed as vector addition. Vector addition means you add coordinate by coordinate. So every one of these 0, 0, 0 will be added to 0, 0, 255. So 0 plus 0 is 0, 0 plus 0 is 0. 0 plus 255 is going to be replaced by 255, and by doing that, I will have everything as 0, 0, 255. Okay? So that's going to be my idea. All right, now all I have to do is replace the center pixels by 0, 0, 255. How do I do that? Well, I do it by going back to catnp, and I have to do some view of the array. So it's 400 by 400. Half of 400 is 200, right? 200 minus 20 would be 180. 200 plus 20 would be 220. So for the x coordinates, I'm going to choose from 180 until, actually this will end at 219, so that's 40 pixels right there. And then I'm going to do the same thing, 180 to 220. And then I have to choose all three. So I can either do 0 to 3. That's one way to do it. That's choosing all three vectors, the vector components, all three numbers, like this. Or if you're choosing everything, a shortcut is just do colon, and that just chooses everything. Okay? So I'm taking from the entire picture, the center part of the picture, and all the RGB values from that center. Okay? And then what I'm going to do is I'm going to replace those values, whatever it was there, I'm just going to replace the values by what we just had before, np.zeros. I want 40 by 40 by 3. Now, I could also do d-type uint8, but because I am putting this into the left side where this has uint8 as the d-type, I don't really have to worry about the d-type here. It will be automatically converted. Okay, and then we're going to do add np.array of the same thing that we had before, 0, 0, 255. Okay, and now what happened is that the middle ones are now replaced by blue. Okay, now how are we going to view this? Well, we'll have to say cat2 is image dot is it from array cat np. So numpy array is now converted back into image. And then if I do cat2.show, okay, you see the blue square at the middle? Right. Yeah. So we can see that there's a blue square in the middle because we've changed the middle, the information in the middle. Okay. And then if you want to save this, cat2.save. And then you want to save it as cat.jpg. And then what is import os cwd. Where am I? My user is total. Let's see. Users. Okay, there it is. There's my cat picture. All right, so there it is.